Okay, so this is the topic before we break for lunch. And I think in the afternoon, you will learn more about how to create this, what are the different tools that are available for creating metadata and provenance in your domain. Uh, so I'm going to sort of introduce the basic idea of what metadata is, why it is important, what provenance is. So here is the list of what we are going to look at briefly. And also look at, the connection between metadata and FAIR principles. Okay, so what is metadata? I think by now you already know that, you use that, you have been using that. So to me, it is not just a question of finding data. So one may ask, we have Google and other research tools available, such tools. Why do we have to worry about how to find data? That's only one aspect, but this is a natural question for the current generation who have grown up after the Google was born or don't know much about what was there before that. But remember that data was being collected and used even before the advent of Google and other search engines and tools. So, it was important to find the data, if not as easily as you can today. Those tools may help you find some of the metadata, but understanding them, figuring out where they came from, lineage or provenance, how trustworthy they are, that's very important in many domains, are separate problems not addressed by search. Search throws up, and it may throw up a lot of data. I mean, one caution I tell my students is searching is good, but you need to be able to filter or discriminate what you get out of search. Not everything that comes up is relevant or meaningful. You should not just get carried away. Also, even with those tools, one may not be able to locate data in the hidden part or part of the databases that are not visible. So that's one of the reasons why we need a better uniform mechanism, not only to locate data, but understanding it and using it. So here is an interesting exchange I found, which sort of sheds some light on the need for metadata, why we are so preoccupied with metadata, because it takes a lot of effort for someone to put all that information for someone else to use it. So here is an exchange. So how do I extract metadata from Google Earth? This is from your domain. I download the cycle image from Google Earth Pro. I want to know date, resolution, server from which the image was taken. As far as I know, Google Earth servers around the world, and the resolution provided by each server varies. Therefore, I'd like to know some information. So, which meant that this information was not readily available when they searched and used Google Earth. But one of the answers that was given for this is the following. Google does not provide metadata for many images that get combined into satellite views or mosaics. But in the Google Earth Pro, using a combination of historical imagery tool, the image date reported in the status bar, and the copyright strings, you can usually figure out the date and provide it. That said, if imagery is very high resolution, then it's probably aerial imagery, which is mosaic from many photos flooded. So certainly there is a need, because without proper metadata, what you're doing is some kind of guesswork, maybe educated guesswork, but you have to know how to do that. Without that information, the very fact that somebody posted it means that information is not really available. So kind of to me, it quantifies the need for why metadata is important, where it should be available. So Data versus metadata. So data is what we use for understanding analysis and applying the analysis we want to do, whether it's AI, machine learning, or anything else, for deriving inferences or for visualization or whatever you're trying to do. Data is also used for visualization and presentation. For example, using the sensor data example that we had, you can obtain demographics information. But if you are given just a piece of data such as this one, how do you use it without any additional explanation or information? So that is where data itself is many times useless unless you know what the data is and you can figure out what it is and then use it. So this is a real problem. And at the end, I'll show you some examples of how computer science people manage, not as good as you guys, to have a very strict way of doing things. So, so as you can see, data by itself is difficult or impossible to understand, not useful for analysis. Merely providing raw data is almost useless for everyone except the person who generated it. And even that person has to remember that it was if they're generating other data. Given the size, ubiquity, and complexity of data available for use, there has to be some way to add additional information to understand, interpret, and use it. And that's where the role of metadata comes in. So simply put, this is the role of metadata, which essentially is data about data, or data that describes other data. So the concept seems to have come from, it's not new, it comes from library catalogs. So libraries existed even before computers. And one of the issues they faced was the same thing. They had a lot of information, but they did not know how to find, search, and other things. So library catalogs were created as metadata and all the delete, decimal notation, and I think so. So the notion of metadata and the need for metadata is not just because you have digital data. This is applicable to non-digital data as well. So certainly metadata is useful for humans who will be using the data for analysis or any other purpose. For example, once you have the description of the census data, you know how to use it. So here is what we showed. This is perhaps a very simple, minimal way to describe it. Does not show any lineage, does not show any provenance, does not show versions, and other things. Who collected it, when it was collected. So here is a definition of metadata from EDC. You are familiar with it. Metadata is information about data. Similar to a library catalog record, metadata records document who, what, when, where, how, and why of a data source. Geospatial metadata describes maps, geographic information systems, files, imagery, and other location-based data sources. Creation date of the GS data is an example. GS data author, contact information, source agency, map projection, coordination system use, scale, error, explanation of symbology. All of these are important for someone in that domain to understand what this data represents. That is the more complex the domain is, the more metadata you will need. A lot of structural metadata comes with Gmail. So metadata is not unique to USGS, or it's one, everything we do. When you send a Gmail, for example, if you go to Gmail, you can look at the metadata that is generated for every email that is sent by you, which is typically hidden and not shown unless you go and look at it. This is mainly machine generated. So essentially it contains IP addresses, date stamps, and various other, how many how many nodes it made and hopped through to reach the destination. I think so. But all of them are useful information for somebody who wants to do forensics, for example, with Gmail. This is very useful in a lot of criminal cases where they want to detect the lineage of the Gmail, where it originated, where it came, how it came. For other data sets, the purpose is different. NIST, which is another agency which is a National Institute of Standards, has a similar definition: information describing the characteristic of data, including structural metadata describing data structures, data formats, syntax, semantics, and descriptive metadata describing. So, sort of the definition, there is agreement on the definition of what metadata is. Metadata is also data. So metadata is not something unique or different. It is data, but the intent and purpose of the data is slightly different from the data itself. There are pieces of information that have some meaning in relation to another piece of information. They can be created, managed, and preserved like any other data. So metadata can be applied to anything. So any piece of information, any piece of data, even physical entities, can have metadata. So a computer file can be described in the same way that a book or a piece of art can be described. For example, both can have a title, author, year. Metadata should be documented for research outputs of anything. So even the output that you do from the analysis is in the form of data. And if somebody wants to understand that data, there has to be some information about data for understanding it. Metadata typically has very little value on their own, but not always the case. Metadata adds value to other pieces of information, but are usually not valuable in themselves. There are exceptions, of course, such as text transcription of an audio file. Even though this is seen as metadata, this is pretty good to understand the data itself in some way. So you can have metadata over a painting. So whenever there is an auction by one of the famous painters, so there is a lineage and trustworthiness of whether this is the correct thing and comes from the source it is described. So there are different types of metadata. Descriptive metadata consists of information about the content and context of your data, title, creator, subject, keywords, and description. Structural metadata describes the physical structure of content data. Camera used, aperture, exposure, file format, relation to other data files. And these are just examples. There is also in the literature, it's the administrative metadata or information used to manage the data. When and how they were created, who can access them, software required to use them, in copyright, permissions, licenses. This can also be used for provenance. So here is a sort of recommended list of minimum metadata elements that should accompany any piece of data. So the following are recommended as a minimum set of metadata elements. It's important to select a metadata standard or schema appropriate to your discipline and our repository, and conserve that schema for complete information on each element. You may choose to use more elements based on the need of your project, the expectations of your discipline. So this is very important. I know it is somewhat difficult to enforce this, and some of the repositories may do that. They may not let you upload data into the repository unless you fill in the appropriate forms of metadata associated with it and in an application. So that is certainly enforceable to some extent, but may not be always. Title, name given to the result, description. format. File format is very important because the extensions of the file format many times are used to understand the type of file, what it contains, and the format in which it is stored. And if you don't use a consistent extension, then it can lead to inconsistent analysis. Metadata, description of the metadata to be provided, along with the generated data and the discussion of the metadata standards used, including the version of the schema and where the data came. Identifier, so this is a unique persistent identifiers such as DOI or ArcID. This has been discussed earlier, assigned to the resource usually generated by the repository. Rights holder, the entities or persons hold the rights to the data. This is important because sometimes they ask you to cite in a specific way when you use the information from that source. The rights information about the rights held in and or the source contact information. So this is kind of a minimal requirement. Here are more detailed, complete list of metadata that can be associated with the piece of data. I won't go into the details of this, but you can see that metadata can be categorized, has been categorized into on the function itself in information management. Administrative metadata, the one I have tried to highlight in green are the ones that I think should be minimally given as part of metadata: descriptive metadata, legal metadata, provenance, structural metadata, use metadata. These are very important. Each one of them, I'm sure there is a one or more standards associated with how to give it, or what kind of data. There should also be templates associated with that, using which you can create this metadata and submit it to the system. Metadata standards and schema. So we saw the concept of a schema when we talked about relational DB. So schema is nothing but a format description. Just like we had a format description for a table, you also can have a format description for metadata. So in order to be useful, metadata needs to be standardized. So we see standardization comes in not only just for applications, but I think data is very important. This includes agreeing on a language, spelling, terminology, date format. If no standard is used, it can be very difficult to compare different data sets. The key component of metadata is the schema. Metadata schema outlines the overall structure for the data. A metadata schema describes how the metadata is set up and usually addresses standards for common components of metadata like dates, names, and places and their formats. There are also discipline-specific schemas used to address special elements to are needed by given discipline. So certainly, it is not the same metadata that needs to be given for every piece of data in a gene domain, that some kind of information may be different. In a biological domain, it may be different. In computer science, I'll show you a little bit later, it is somewhat different. So here are some standards that I saw that are used, that are widely available. So this is an old one, just for completeness. Dublin Core seems to be a standard used by libraries. This is a enriched, revised Dublin Core. So Darwin Core, as I said, used for describing biological specimens, and their intent may be slightly different from USGS and your interest. NASA standards. NASA has a variety of data formats that it uses, perhaps it, and then FGDC has its own format. This schema is for geospatial data. You will learn about tools for creating it in the afternoon. So certainly this is what you want to focus on. So who consumes metadata? So the important thing many times to understand is not just the humans, just like data is maybe visualized, understood, but consumed for analysis by the computers, metadata can also be done in the same way. So what if a human, what if the non-human wants to use the metadata and perform some operations or analysis on data based on that? The format that is good for humans may not be appropriate. So this is an important issue that comes up because we want to use automation, computation as much as possible. To do that, we can do things manually. Hence, there's also need for metadata that can be used, understood, or consumed by computers. And RDF was specifically proposed, known as the resource description format, is one of them. RDF specifies triples with resources in subject and object. They can be URL. So this is used for describing resources where you can find additional information, has been used for taxonomy very widely and extensively. It is also used in semantic web, Web 2.0 and Web 3.0. So this is quite commonly used in many computer science applications that deal with semantic web. RDF is a standard model for data interchange on the web. Other technologies such as OWL build on RDF and provide language for defining structured web-based ontologies, which enable richer integration and interoperability of data. I don't know whether RDF is popular in your domain. I'm not really sure, but that is something that that is available, is widely used. Search engines can use the information available to make search more focused. RDF can be used to integrate data from multiple sources. RDF can be used to build what we call labeled directed graphs. So it's a triple which essentially describes one edge with the source node and the destination node, and the properties of the source and destination nodes, including the edge, in terms of labels or resources where additional information is provided. So it's domain independent, so it can be used in any domain. Can also think of metadata for metadata. So similar to, we have this known as higher order logics. We have proportional logic, first order logic, second order logic, third order logic, and that is very similar to data, metadata, metadata, so on and so forth. So metadata can be generated either manually or through automation. And the difference is manual creation increases accuracy and can provide better description. So automated generation typically cannot provide description, but provide other components as compared to automated means, which may generate information such as file size, extension, creation date, version number, etc., which are useful, but they are not the same as the description. I'm not sure how many of you might have heard of something called Amazon Turk. This is something we use for our research very often. So if we want something to be annotated manually, and we want to do it for large amounts of data using expertise from the crowd, so kind of the crowdsourcing, you can use something known as Amazon Turk. This is provided by Amazon. So you can upload this information and you can invite people to do this annotation. You can pay them. You can say, for each question answered, we'll pay you 10 cents. And then we can also put certain qualifications that they should have in order to do that, so that not everyone comes and does that. And also we limit the amount of things they do. This is very widely used in manually annotating what we call fake news. There's plenty of them these days going around. So there's a lot of research going on what news is fake and what news is not fake. But the ground truth for that is extremely difficult to understand or obtain. What is true? So that's where we use manual annotation and manual schemes using Amazon Cloud for that. RDF was originally designed as a data model for metadata representing information about resources in web, commonly used for description and exchange of graph data because triples they express graphs one edge at a time, and using that you can build an entire label graph. So they consist of triples, and some of them can be yours. They use a language, there's a language that is developed called Sparkle, which is similar to SQL as the query language to query RDF triples. Triples can be combined to form a knowledge graph. So I don't know if you are familiar with it, the notion of a knowledge graph is quite widely used. So this is a general graph which can store in general information. This was available earlier as a free thing. I think Google bought it at some point in time. They use it for their search. So they use it for their search. For example, they create this knowledge graph from Wikipedia. Using information in the Wikipedia, they can identify entities and relationships and other things and construct this graph and then use this graph. So that's one of the reasons perhaps why Google search is so much better than other search engines that we see today. And it uses a lot of different kinds of information and pieces to do that. While metadata provides unique contextual information about a set of data, it does not, strictly speaking, provide content. So metadata does not contain the content. It is the data about the content. Metadata can tell you when a message was sent, but it won't tell you what the actual message is. So metadata is still very useful for various purposes where privacy is involved, where you don't look at the message, but you can look at the metadata. Similarly, metadata can tell you where a picture was taken, but it won't let you see the actual picture. Of course, a lot of value can still be uncovered. Our interest is to use metadata to find, access, and understand data that we use for various purposes. Interoperability, reusability can be made possible with appropriate metadata and to support fair principles. So the uses of metadata are typically enabling data discovery, understanding data based on that, doing analysis and synthesis, maintaining longevity of data, tracking the progress of research project and demonstrating the return on investment for research at an institution, lineage, and various trustworthiness of the data. So these are the various uses of the data. So here also, I just put this so here are some standards that I took from USDC to show you different type of standards and the support, XML support that is available for that we discussed earlier. So for example, if I click on this XML, you will see the XML format. So this is what I tried to show you earlier, which is not very human friendly. But if I click on the style sheet, the same information is shown what contained in the XML I showed you in a human readable, visually appealing format. So this is the piece of information that it contains. So you can see here the metadata that is associated, that is stored as an XML file that can be processed by an application or a piece of software, but that can also be visualized by the human and understand what it's about. So that is the importance of using something like XML or JSON. So XML is popular because it has more expressiveness. You can express hierarchical. For geospatial data, let me just show you one. And so here is an example of mineral resource data for the US Geological Survey, blah, blah, blah. And here is the metadata associated with that. It is pretty long. You can see this metadata is very extensive. I don't know how much time and effort it takes for you people to digest this for doing the analysis, but there is extensive metadata that's available. Similarly, for any of these formats, so for databases I have seen, let me see what it looks like. Geochemical database from iron oxide copper. So this has a lot of information as well. So this is how I guess you may be using some of this in the afternoon for creating these metadata. So coming to data provenance, best way I can try to make you understand this is think of ancestry.com. So that's what it is. So data lineage is trying to identify the lineage of the data and how it has come to this point and where it started. So that is the whole point of that. So data provenance or lineage is the equivalent of finding something on this. Refers to a record trail that accounts for the origin of a piece of data in a document, database, or repository, together with an explanation of how and why it got to the present place. Word documents carry some. So if you look at the Word documents, go and look at the properties, for example, there is some metadata associated with every document. The spreadsheets have some information. Even the X-ray and the MRI you take have some metadata associated with it, which machine took it, what kind of resolution. All this is not visible to everyone, but it is available. Word documents carry that, sometimes referred to as 5 Ws, who, why, what, where, and when. Provenance is an important issue for scientific data, where it is central to the validation of the results. So you cannot validate results or trustworthiness of what you're getting without understanding where this data originated and how that makes you understand whether the data is legit or not. Certainly, agency like CIA has a lot of difficulty with lineage data because it's very difficult to get and they have to make. So there's notion of confidence that is associated with data in human intel data.
Dr. Sharma, I just wanted to let you know it's about 8 minutes, 9 minutes now past 12:30.
Oh, I thought I was going up to 12:45 now.
Oh, is it 12:40? Okay, yeah,
No,
we can do that too.
no, is it? I'm not sure. I might have misread it. That was in the back of my mind. So you can tell me. Let me see. I have more slides. So I don't. I'll just finish this one and leave it the others ones for all examples. So yeah, it is
Okay.
for also. So uh, okay, so data traceability is very important. Provenance in healthcare, for example, because you are making life and death decisions, treatment decisions based upon that. USDC data as well. I mean, I just put it because, a wrong place was found in Yugoslavia in 1999 because it was not updated in the database or the provenance was not clear. Traceability and trustworthiness depend upon data provenance. For example, clinical trial data is more trustworthy if the trial is large, replicable, randomized, and this one. I will skip this because this has been gone over on the first day, I remember, by Professor Eisman. So this is the same things, what is the synergy with FAIR principles? And, for findability, there are some for accessibility and for, so I'll skip that. So what I have is, along with unique and persistent identifiers, metadata is considered the cornerstone of FAIR principles, guiding scientific data. The challenges, though, is produce richly described metadata, evaluating digital object fairness. Some of this will be discussed in the afternoon. So just briefly, this is not quick. I just want to give you a contrast with how metadata is managed in our domain. If you Google this set of words, this is what you get. It just lists a bunch of stuff. And let me just show one example, and I'll wrap it up. So this is a repository that is used by a lot of computer science research. This is maintained by Stanford. But you can see that the amount of metadata is very limited. So here is name, type, description of the entire data set, not the individual fields. So this is the level of metadata that you see in our domain. Unfortunately, sometimes we have a data set, but we don't have enough metadata information to understand and use it. So that is a big problem in our domain. So again, here is another one. I will not go into that. You can click on this and see how sparse it is. So just to summarize, efforts in creating metadata using guidelines along with figures go a long way in the access and meaningful data. That is the key. When the data sets are very large and complex, this is even more important. It's important to pay attention to both metadata creation as well as whether they conform to their principles. We'll be learning more about metadata creation. Data provenance is critical. So I'm going to wrap up. I'm sorry I misunderstood. I didn't remember this one. I'm going to stop here, answer any questions, and I hope I did not cut into the afternoon time.